So I'll introduce you to Arunab. He is someone who's got a knack for coding and has been serving Curl Tech for last 5 years. And we are truly, truly honored to have you here, Arunab. We are looking forward to listen to you and learn from you a lot. And I would also like to tell all of you that Arnab has won a lot of hackathons and has that great sense of logic and coding, and then working on the most emerging technology, which is blockchain. And today, it's going to be a real pleasure to listen right from him. And without any further ado, I would also like to thank you first for letting us meet Arnab in person and learn from him. So, Arnab, over to you. It's your time altogether, all yours, and then we'll have a small Q&A at the end and take questions from the audience.
Thanks a lot for such praisey words. I'm honored. Just a little bit of correction though. I'm working with Curl Tech for last 2.5 years, not 5 years. I've worked experience for 5 years. Yeah.
Okay, I'm sorry for that.
No problem. Okay then. I think we have our audience already in place, right? They are listening to us.
Yes. Yes.
Cool. So I start. Oh, cool. I think it's up. Okay, so hello all of you. Today we will be talking about blockchain. It will be basically an introduction where I will introduce all of you to what this is, because it has been hype for many years now, and a lot of people do not understand it. They may think it's too technical or something too advanced, and it's difficult when you look at it holistically to understand blockchain. So I would like to simplify it for you, and in this talk, I intend to provide a path for you where you can explore this technology. So I think we should get started. Now, most of us know about blockchain that is started from Bitcoin, but this concept was coined. One second. Yeah, but this concept was coined back in 1991. Even before that, something on the same line was scientists were working on something on the same line. So this is just an article that I took from a website called Java Tea Point. In 1991, few researchers was trying to introduce a computationally practical solution for time stamping digital documents. The sole intention was some documents shall not be backdated or tampered. This was one of the biggest problems that they have. And blockchain also contains a history of such events, which led to the final creation of the technology that we call blockchain. It's an amalgamation of cryptography, distributed computing, and a few more technology, which we'll talk in a certain point. So I would urge you all to read about the history of blockchain as well, but that's for later. Right now, there are a few concepts that we might want to know about before we start a journey towards blockchain. And these are the things: hashing, nodes. Well, this is something that most of you would know, but to a non-technical, it might sound confusing. Timestamp server, consensus, and nonce. This is a rather big list, but for the scope of this talk, I confined it to these 5 concepts. So let's tackle each of them one by one so that we can continue. Yeah. So let's tackle each of them one by one so that we can better understand the blockchain, what it is. So the first thing first, start with hashing. Now, rather than explaining you what hashing is, I would prefer to show you this. I guess. So this is a demo that has been prepared. Now, hashing is an algorithm or a logic formula, you can say, if you're not technical, if you're not into computer science. So hashing converts anything into a set of number that is which size is fixed by the algorithm. So if you write if I write my name here, this is the hash that it gets generated. If I make it captcha, it's a different hash. See, even a slight change in this will change the hash drastically. It's an algorithm. For those interested, they must explore this. But for rest of us, we should just know that it's a black box, that whatever you give it in input, it gives an output that is of a fixed length. For this is a SHA-256 hash. This is nothing, just a name of the algorithm, SHA, and 256-bit hash. Bit is directly proportional to length of the generated hash. Okay, in this case it's a 256-bit hash. So this hash, the most common use of this hash is to verify that data is what they claim. You give me a file, I will create a hash and record it. Anytime you give me a file, I can always verify that this is the same thing. It is possible cryptographically. So this is the first concept, hashing, which most of you by now would have known. But anyway, the second thing that we want to talk is nodes. Well, there's a very simple thing. In a context of a network, any computer that is attached to it, we term them as nodes. So it's nothing but a computer that's connected, that's part of a network. Uh, just mentioned it for those who are totally new, who are unaware of the term. And now we have heavily used cryptography. Like cryptography is one of the building block of blockchain, and it contains a lot of encryption, decryption, a lot of other things, which you guys can explore on need basis, or if you have to study that, it's different. But one thing that we are highly interested on before starting our journey to blockchain is nonce. Nonce in cryptography is a number that can be used just to make things difficult. Like it's a random or a pseudo random. By pseudo random, we mean a number that's not following a pattern, but still it's there are limitations that we put on that number. So a nonce is an arbitrary number that we use in cryptography to support our algorithm or make cracking it more difficult. For example, if we say 2 plus 2 is 4, and let's say we in any answer we add 040. So someone who don't know what formula you are using to get 4, he would have to he will get 4040. It's a bigger number that we are adding a nonce to it. Just wait on for a minute. I will visually show you how this works when the time comes eventually in this talk. So this is nonce. If anyone has a problem or a question, feel free to type it in so that I can quickly take that up as well. Now, simpler things aside, the next important thing we want to talk about is a timestamp server. So what a timestamp server is, as we just learned what hashing is, it takes hash of a block of item or a list of items and timestamp them. Then what it does, it is publishes it to the network. Everyone who is a part of the network or who has subscribed to this server get uh, will get this hash thing along with the timestamp. And no matter which part of the country or the world you are in, the timestamp shall be same. So this statement is taken straight from Satoshi Nakamoto's white paper, Bitcoin white paper, which I'll talk about in a minute. So this he has compared it to a newspaper. For example, newspaper, there's an article which is distributed to all its subscribers, and they have a copy of this newspaper, and they can every time verify, like, on this date, this was the information that was put in there. So for if you are not interested in delving technically on networking concepts, timestamp server is just a simple server that can distribute any information along with a timestamp to its subscriber, and that's it. But how is it achieved? It's an interesting topic. I urge the interested party to explore this as well. So, what advantage does this give? This timestamp server proves that data must have existed at the time when it was delivered to its subscriber. And obviously, in order to get into the hash. Otherwise, now this second part of the statement, like obviously, in order to get into the hash, I will explain a little bit later. This is the parent concept of how what is the blockchain. So each timestamp now includes previous timestamp in its hash. So for example, there's a transaction, it is attached to a timestamp, and we also include a hash of previous transaction along with its timestamp. So we can provide a proof of sequence, like these are the transactions that happened in this particular sequence at this particular time. So this is rather difficult to tamper with. Okay, so this is also one of the prerequisite timestamp server. Now, moving on, we'll talk about consensus. Kindly do not read the rest of the statement until I ask you. Consensus, by definition, means agreement. Now, when there is a dispute or when there is a transaction is not just a sending money or anything, it's anything that matters in the transaction. You you giving out a statement is also a transaction that you said something. So consensus in this context is way to a way is to come to an agreement among all the stakeholders that this is a transaction that has happened and in this order in case of blockchains. Okay, so just this is consensus. And right now, we will discuss proof of work, which is one of the mechanism to achieve a consensus. Now, before we talk anything else, what happens here is in normal case, when you do a transaction, when you make a payment in Flipkart, Amazon, or something, on your bank account, there is a transaction that gets added by the bank, and you and bank both has already agreed to a contract that bank will dictate a transaction, it will share it with you, and you both will agree that this has happened. Or you can raise a dispute, reverse that transaction, and things like that. So in this case, when we are trying to achieve when we are trying to do blockchain, we try to avoid this banking party, which I'll talk eventually. But in doing that, who is going to agree or prove that there's one transaction that has happened? Basically, it's a network, or we can say nodes that are attached to the network, the computers, individual computers. They will somehow cryptographically, without any human intervention, will be able to verify it. So to verify it, they need to come to an agreement like this is a set of transactions that has happened. And that's consensus. So there is so we first talk about proof of work, what it means, how it works. So now you may read the slide if you haven't yet. The proof of work involves solving a mathematical puzzle, is- which is scanning for a value that when has, such as with SHA-256, the one I showed you right here. Okay, the hash begins with a number of 0 bits. So as you are able to see for this data, this is the hash generated. Now I want to add something, which is nonce. It's a meaningless number, as we discussed in a couple of slides ago, which I will add. So let's do that. I'll add 1, then 2, then 3, then 4, 5. I will keep checking for each of the nonce. And what my end goal is, I want to get a hash that starts with a set of zeros, 20, 30, 40, and this is the puzzle that I need to solve. So if let's say if I add 65,980, this is another hash, but it does not start with zeros, right? Now, okay, let me just set this. So now We'll click here. This is how a block looks like. Just a second. Yeah. So now this is a block number that could be one. We'll talk about it later, but we have a nonce here and a data here. Let's say you add a data. Aruna is something. Just my name. Any data it can be. I will eventually show you how a transaction looks like in the blockchain. So this is a nonce. Okay, I see I have a message. Yakshi Arora. Can you explain a bit for introduction? Can you specifically ask your question, and within a couple of minutes I will respond to you, please? So now what I was explaining you is we have this nonce. Let's ignore this for now. We have a block number. We have certain data which we will eventually give it as a list of transactions that is happening, and it's a hash of this much data. So when I click on mine, what this is internally doing is checking with all the different nonce, 1, 2, 3, 4, such that we get a four zeros in the beginning. See, when we use this hash 169316 along with this data, we get this as a hash, which is first four zeros. So that's what nonce is used for. Nonce is just for the purpose of solving this puzzle. We add just a random number that is meaningless, and putting in the right number, we can always get the hash. We can get a hash that starts with four zeros. Now, finding out this nonce is a difficult task, but once we know the nonce, verifying it is just very simple. It's straightforward. Okay. So that's what consensus is. Now, that's so sorry. We are starting to explore proof of work as a consensus mechanism. The average work required is exponential in the number of zeros bits required. What this means is when I ask you to find a hash with 1 0 or 2 0 or 3 0, it would require 2 power 3 times the work that you need to calculate a hash. So when I tell you find me a hash with 10 zeros, it required 2 power 10 times the hash. And now we're talking about 100 or 200. So it is not such a easy task to do it. Okay. But we also know that that with advance in technology, we can calculate faster. Or there's first of all, I want to make sure that you all understand that there is no formula to calculate this nonce. It's mathematically not possible. And if you want to explore that, can you do? But that's a different discussion. It's mathematically not possible to calculate this. We have to check it throughout. You will figure it out when you go ahead with the algorithm, that when you try to understand the hashing algorithm. So all we have to do is check 1, 2, 3, 4 up to a point where we get this thing. So for a timestamp network, we implement proof of work by incrementing a nonce in the block until a value is found. Okay, sorry, value is found. That gives the block's hash with the required number of 0 bits. Once the CPU effort has been expended to make it satisfy the proof of work, the blockchain cannot be changed without redoing the work. Now, the last part of it, please ignore. We'll talk eventually. This is just the prerequisite. So I was trying to explain you proof of work, which will talk about it, which will be using it uh, in the time to come. Okay. So now we have this proof of work. So as we said, like there is 1, 2, 3, we are trying it. So who gets to try it? Now this is a technical term. If you don't understand it, you can totally ignore. In a network, each node or a computer is identified by an IP address. So there was an obvious solution. One IP address will make one vote, like this can be the nonce along with the other details. and that can be accepted. But the problem was, uh, a person or one particular node can have a way to allocate multiple IP address and all those things. So, and this is a mathematical computation. So we concluded that one CPU should get one vote, and this way, it is a bit difficult to tamper with it until you have a majority of the CPU power. So, so for those of you who know, back in 2010, 11, or 12, you could mine a Bitcoin using your personal computer, which was running mostly Pentium or something. But right now, even the fastest i7, i9, or the GPUs are not good enough. You have integrated chip because entire network of blockchain miners have upgraded to this, and one second. Entire network of blockchain has upgraded and each of them are contributing with more CPU power, so which is getting matched by others. Now, if a majority of the CPU is controlled by the honest node, the honest chain will grow fastest and outpace the competing chain. Here, try to understand this. Let's say what we do is this is a block which contains let's say a list of transactions. Now all our task is to calculate the nonce and submit it. The network will accept and reward you with something, and that will be added as a block which will follow. And all the nodes will start working on the next block. So, as the computation power increases, we in the time that it takes to generate one block becomes lower. So what we have concluded, what Satoshi Nakamoto, not we, concluded is, let's keep it constant. We try to keep the block generation time on average to be 10 minutes. If a block is getting generated faster, next time we increase the difficulty by adding one more zero in the requirement. If it's taking more time, next time we decrease the difficulty. So that's how we try to keep the time that it takes to generate one particular block more or less constant or stable. So this was proof of work. What it does basically, ignoring everything that we talked till now, what it basically does is it helps you to come to a conclusion that this is a set of transactions that has happened in this order, and these are the details of the transaction. That's it. Why we did proof of work? Because we want to give you some incentive to keep a record of this transaction for me. Let's say I'm using this computer to uh, keep record of blockchain or mine block Bitcoin. So I need to get some incentive, and based on who solved this, who is the lucky one, will get a reward of right now I think it's 6.25 Bitcoins. Every successful transaction gets that. So that's the reward. So that's why we do this. Now there is another consensus algorithm that I want to talk before I proceed. Is proof of stake. It's a real world scenario, no algorithm. What it is, so for example, I will take a judicial system, a judge. What he does is he reads the law, analyzes it, analyzes the statement of the lawyers, and give a judgment. We trust him to give correct judgment because it's his reputation is at stake, his entire life work is at stake, and if he lies, he will be penalized and he cannot get away with it. So he must tell the truth. So he has a stake in it to be truthful, and lying is not in his favor. So this is proof of stake, and that's also mechanically implemented in a lot of different blockchain. Ethereum is moving towards proof of a stake. So this has been consensus. This is one of the most important topics. Now, for anyone, prerequisites are done. For anyone who at all wants to explore blockchain, I recommend them to read Bitcoin's white paper. It's a 9-page document, very simple. If you don't want to get into technical detail, you can always skip that, and this document will still make sense. And this is one of the finest documents that can give you an idea of what blockchain, or an idea about it, almost everything. So this is an excerpt from that document, which I will start with. The problem that Nakamoto identified in the current payment system. The first one is commerce on the internet has come to rely almost exclusively on financial institutions serving as the trusted party. Now, what's the problem with that? Well, the system works well enough for most transactions. It still suffers the inherent weakness of trust-based model. That is, completely non-reversible transactions are not really possible. This means that you can, once you do a transaction, if there's a dispute, they can always undo it. For example, by mistake, if you get the money, if I enter wrong account number, you get the money, you can always reverse this transaction. Although it's useful in solving those disputes, but still there is a cost attached to it because someone has to work towards it, and that cost normally limits the minimum practical transaction size. Well, why this is a problem? It's debatable, and let's put this out of the scope right now. Okay, there's and then there's one more problem. With the possibility of reversal, that a transaction can be reversed, there is a need for trust between the parties that are involved in the transaction. Merchants must be wary of the customer, hassling them for more information than they would otherwise need. So this is one of the problems that I was identified by Nakamoto. A certain percentage of fraud is accepted as unavoidable, and then the cost of payment uncertainties can be avoided in person by using physical currency, but no mechanism exists to make payments over a communication channel without a trusted party. Now, this is a summary of problem that Nakamoto identified before, and this is how he started his paper of Bitcoin white paper. So, as I already talked about it, let's see what he proposes as a solution. There are many other problems that you can think of, and you might have known if you have watched the videos on YouTube or any other articles. So let's see what is the solution that he proposes. What he says is electronic payment system that is based on a cryptographic proof instead of trusting a bank or any organization, allowing any two willing parties to transact directly with each other without the need for a trusted third party. Okay, that's one. Transactions that are computationally impractical to reverse. Once it's that we already know. So on a blockchain, if we do a transaction, it cannot be reversed. But there's also one example where it happened, which I would urge you to read about. It happened on Ethereum network back in 2016 or 13, I don't remember. But I would like you to read about it. So, and he also said in the context that we can implement escrow mechanism to protect the buyers. Escrow is nothing but a temporary account holding the amount until a transaction is done. We'll talk about it. And we propose a solution to the double spending problem using peer-to-peer distributed timestamp server to generate computational proof of chronological order of transaction. Now, we just scratched the surface of double spending problem because you guys might not have. I have not introduced you to this problem, so it's not wise to get into detail of. We can all, but it is a very important point. Now, let's see what a transaction in this new system looks like. What we do is there is a coin. Coin is just a currency in the context of the blockchain, of particular blockchain, in this case, Bitcoin. So there is a coin. Now, there's also one more concept that has to come as a part of prerequisite, which is public key, asymmetric key, and asymmetric key cryptography, encryption. Sorry. So this is a example of here. What we have is there's one public key, there's one private key. Private key is something considered as my password. Public key you can consider as my email address. I will share my public key with network, but without private key, you can just look at it and verify and not do a transaction. So for each transaction, owner one shares a public key, hash of the previous transaction, and owner zero's signature. Signature is a way of verifying it digitally that I agree to this. Okay. So let's say if a particular coin, a particular 10 rupee note, you see a number, let's say that's a coin. So what you're trying to do is you transfer that coin to from owner zero to owner one. You create a transaction that looks like this. Once that happens, well, let's say owner one gives it to someone else. There will be another transaction that will look like this. So it's how the transaction is. I will also visually show you how I will also visually show you these steps. But this is one transaction. Now there are a few problems with this. The first inherent problem is double spending the coin. Now everything is digital. You don't have a physical copy there. I can simply try to do it multiple times. As you already know, like doing a Bitcoin transaction takes around 5 to 10 minutes of time. So let's say in that time, I'm Flipkart, Amazon, both of them are accepting this Bitcoin. I try to uh, buy something with the same 100 rupees that I have on Amazon and Flipkart. So they should not get accepted and only one. So the problem here is Pay can't verify that one of the owners did not double spend the coin or multi-spend for that matter. Introduction to a trusted center. Now, the solution was let's introduce a trusted central authority that checks every transaction before for double spending. And it's like, yeah, if I'm checking all transactions, you can't do it. But here comes the basic idea of it. That will make it into another bank, which we were running away from. So what's the solution that Satoshi Nakamoto proposed is let's publicly announce all the transaction. Now there's a privacy concern which we will address, but let's publicly announce all the transaction. Then there is no point of double spending or any fraud that's possible until unless the public who is keeping a record is correct, which is which we will incentivize them to not be corrupt. So basically what a blockchain does is we have a transaction, we can cryptographically verify that all these transactions happen in this particular order. We have a timestamp server using which we can always distribute it among the network, and all of the network we give them a puzzle, or they have their stake in the networks, and somehow they are being incentivized to be truthful. Okay, so there's a reward to be truthful. All of them are keeping record, and we can always verify if anything has been tampered. That's the crux of blockchain. So now we are publicly announcing the transaction as well. Okay. Now, publicly announcing the transaction would lead to uh, all of them. Sorry, I think I repeated myself. Now, okay, so let's simplify what happens in a network or how to run this. This is also taken from Satoshi Nakamoto's Bitcoin white paper. The steps to run a network is simply once the new transactions are there, broadcast to all the nodes. Each node collects this new transaction in a block. Each node works on finding a difficult proof of work for its block, as we already discussed. When a node finds a proof of work, it broadcasts the block to all the nodes. All the other nodes have just need to verify and accept it. Nodes accept the block only if all transactions inside of it are valid and not already spent. Now, because of time constraint, I'm not talking about how the transaction is getting validated, but we can assume it does. Now, once they accept this node, they start working on the other next node, next block, using the hash of the previous block. So that's how a blockchain network works. So we have already talked about the incentive that we are giving. It could be a reward for mining, which happens in case of Bitcoin. Once you find a correct nonce and you submit a transaction, it's accepted, you are rewarded up to a 6.25 Bitcoin right now, which gets halved every 4 years. It could also be transaction fees. For each transaction, we are reducing a small amount, and that will be given to the successful miner. Now, so eventually, when there is a huge amount of transaction already happened, and the reward for a new coin that's created is of very small value, we can shift to this transaction fee, and that's what the plan with Bitcoin is. We can discuss on it later. Now, the incentive may help encourage nodes to stay honest. If a greedy attacker is able to assemble more CPU power than all the honest nodes, he would have to choose between using it to defraud. Like, let's say if someone owns 60% of the power, he will still need to, he will, this incentive will still be profitable to be truthful, as he's also getting this huge amount of reward rather than lying and doing something else. So uh, that means even to an attacker, this will become a game of loss if it is not able, if he tries to do fraud. So this incentive is the only thing that's holding Bitcoin network together. Okay. Now, now we talked about publicly announcing all the transactions. So there's all obviously a privacy concern. In the traditional banking model, right now whatever you're doing, you are doing the transaction and submitting it to a bank. There is a certain level of privacy because they won't provide access to your transactions to anyone without your permission or without until the law says. But the necessity to announce all transactions. Now, this is not true for all blockchain. Only when we are using proof of work as a consensus, we need this to announce our transactions publicly. And this was a case of Bitcoin. So when we do this, we need to think about privacy on a different aspect. What we're actually doing here is we are what we're showing to the public is this is the amount of transaction and this is the public my public key, and the public key gets generated every time you try to do it. There's a mechanism to do it, which includes two algorithms, RSA and ECDSA. You can explore them, working of these algorithms very easily. So this public key cannot be linked back to any individual or any party involved. So what we announce publicly cannot possibly link back to us. And that's how we maintain privacy in case of Bitcoin network. And there's similar ways we do it for other blockchain. Now, okay, I think it's already 40 minutes in, but still there's two more points that I want to discuss. First, this was the block that we see. Let's say what a blockchain looks like. Let's see what a blockchain looks like. Now, there's one data here. Let's say I insert a name, I mine it. What happens? This is the nonce that we work for. This is the previous hash because it's the first block. We call it Genesis. And this is a hash with 4 zeros. Now, all these other blocks turn red because I changed something in there. When I mine this, now because this has been updated, which is reflecting here, we need another hash here. And based on this new hash, the third transaction that is over here needs to be remined. So if I change anything in a particular transaction, everything that follows needs to be changed. Yeah. This is a block consists of a list of transactions. These blocks are linked together like this. And each of them we do proof of work in this case, which is we calculate a nonce that satisfies a condition of number of zeros that a hash should start with, which takes, let's say, 10 minutes of time come with all the combined computing power that we have, because we are trying in algorithm we try to restrict this time by increasing and decreasing the difficulty levels automatically. Okay, so this is a chain of blocks, chain of transaction, set of transaction, a block, chain of block, which cannot be tampered or backdated until unless there is a if we do this, there's a huge amount of work that needs to be done. Okay. Now, what we do here in case of blockchain is we distribute it across nodes. Okay. All these nodes have the same set of blocks, which contains exactly same transaction, which can be always be verified by the hash. Now, let's say I change a transaction here, one faulty node, which does something like this. He mines one transaction. That's true. He mines another, and he mines all the following transaction, which takes, let's say, taking 10 minutes for each. So in that time, other blocks are also calculating the fall. See, even this is also taking time. During this time, other blocks are also generating newer blocks, other nodes, because new transactions are happening until it catches up. So as we explained, it's difficult to catch up. This is a valid block, but with a different data. Now, if it does not catch up and other blocks nodes are holding a different set of blockchain, there will be a conflict and a majority wins. So having a fraudulent node here won't help a lot. And as you see how much time it took to change the transaction or go back and change something, then catch up and then proceed. So that's why it's difficult to tamper with a blockchain network, because you have to fight the entire network. Okay. Now then there's the final thing that I want to show you in this demo is tokens. This is how a transaction looks like. This from and to, we have a name here, but it will actually be the public keys and the private keys of it. It won't consist of this name. It's for the sake of simplicity. Amount, yes, that's there. And then, so if anything, same example, if anything gets tampered, you need to mine it all, and you need to see how much time it's taking to mine this, because it contains a lot of transactions. And that is just for the case of 4 or 5 zeros. See, imagine what will happen if we want 15 or 20 zeros. It will be 2 power 20 times this time. And there are many things. The nonce gets bigger, and we are actually able to challenge the calculating power of a blockchain. Okay. So this was, and even though I correct this block, if it is different from others, it's get discarded by the network, and that's how Bitcoin blockchain works. So there's one final point. Till now we talked about the concept, prerequisites, or the cryptographic thing, the consensus of before understanding blockchain, and we only talked about Bitcoin, because I believe that's the starting point to understand the technology for anyone trying to explore it. But let's go beyond Bitcoin. Once we got to know that there's this uh, technology that's available, that we can do a trusted transaction, financial or anything else, and we prove them via cryptography without having anyone telling someone that it's true or false. We can prove it mathematically, basically. Cryptography, you can think of it as mathematically. So what we also thought is we can insert some logic in the blocks, And based on that, we will do a transaction, which gave birth to a smart contract. And one of the pioneer of this smart contract was Ethereum blockchain. So this introduced a smart contract based on logics. We can do a transaction, and that will work exactly same no matter what. So this is also something I would like you guys to explore. Then there was a requirement that because of anything, NDA compliance, whatever, I don't want to publicly announce my blockchain. Well, go with some other consensus mechanism. Then I don't want entire network, anyone to be able to join the network, which is true for all the public blockchains, Bitcoin, Ethereum, etc. I don't want anyone to join the blockchain. I only want it to be confined. Well, there were few challenges, but that gave birth to enterprise blockchain or a permission blockchain. A majority of the use case of a permission blockchain is dealings between multiple companies. That's why it's also named enterprise blockchain. Few of the famous are Hyperledger project by IBM. One of them that is most famous Hyperledger Fabric. Then there is R3 Corda, Quorum, which is built on top of Ethereum blockchain. There's another set of application of this technology. When we are saying all the rules can be implemented, it can do almost everything on its own and verify it's correct or wrong. So there is also a legal system that they are trying to get into blockchain. If these are the conditions that are met, this is the judgment that should follow, and things like that. So there is also a concept of DAO, decentralized autonomous organization. We create an entire organization, bigger corporate company you can imagine, and even right now they all of them work on contract. When joining, you need to sign a contract. While leaving, you need to sign a contract. You need to do some basic things. If not, you will get penalized. If you do your job properly, you will get rewarded. Everything. So all this can also be done using Bitcoin without any human intervention. All the humans will be a part and parcel of this company, and there will be also rules to change the rules, which will also be defined. It's just the contract. So this goes way beyond this. Beyond now, this talk was intended to give you a pathway to explore blockchain, starting with Bitcoin white paper, because it does a wonderful job in explaining you what the essence of the technology, and also explore it further. Whichever is your topic of interest, you can go ahead and explore that part of it. Now, I think I'm ready for the Q&A. That was all I have. So yeah.
Great. Thank you so much. So people, we have 10 minutes wherein you can ask your questions. Just post them in chat and Arunab will take that one by one. So for Yakshi, can you please, Arunab, tell her a little bit about blockchain?
Yeah.
She told she's new to it.
Right. So yeah, there was one thing that I used to tell all my juniors who are starting to the technology. Try to read the Bitcoin white paper, because that does a wonderful job explaining it. It is like one of the Nolan's movie. You need to read it again and again to have a better understanding of it. So for introduction, I would suggest you go with this demo. It does a real good job explaining how a blockchain transaction works. And you can, yeah, that's all for the introduction. You need to explore it further. I see there are chats coming up. What are the other applications of blockchain? So you have seen the financial transaction. We can use it. Basically, what a blockchain can do is it can give you power over over all the information that you have, and it without needing of a human or without a human knowing, it can verify or establish a particular fact. We call it source of truth in this in the context. We call blockchain networks to be a source of truth. So anything where we can use it. There is a land dispute. Land records can be implemented over here. Legal matters can be settled via Bitcoin unless they are complicated. We can include a lower court and then a high court and a Supreme Court. So lower court can be solved by blockchain, on blockchain, although it's difficult to implement. There are real world problems. So there is also an application where you can run an entire organization on blockchain. So there are many things. So there's another question that I want to take is, can you give one example, one problem from India which can be solved from blockchain? Good question. So one problem for India is the medical record thing. One of the biggest one. Right now, when you go to a new hospital, you have to do all the tests. Although the records, your medical record, prescription are kept digitally with a hospital, it's not distributed across a hospital, and you can get, and the hospitals have an incentive to keep those records with themselves. Once a blockchain is in place, obviously there are real world problems with this as well. But once this is in place, you can go to any doctor, share him only the information that he needs. There are sensitive cases as well. So this, I think, is one of the application. There's nothing backing crypto governments, although don't support it. Then why are people investing in it? Okay, that's a good point. So there's nothing backing crypto is kind of understatement. Crypto are not backed by an asset, which is in case of a stocks or something else you might say, but it is backed by the users that are using it. Government doesn't support it because they have few valid reasons, such as avoiding criminal transaction is difficult because it's anonymous, but they also want to manipulate the currency. Um, uh, like a government can increase or decrease the value of a dollar, or some of the policies, like in case of petroleum, will change, manipulate the value, which is not possible in case of crypto. And there are many other reasons based on individual cryptos. It is, I believe, this cryptos can change a lot of things. It's a world-changing technology. Okay, there's another question. With new coins coming up in the cryptocurrency space, swiftly with improved technology, do you think Bitcoin will lose its relevance given its lagging technology in the years to come? Or would the space be more like Bitcoin dominated, but with other cryptocurrencies too, like Ethereum, Cardano, etc., alongside? Well, that's a very interesting point. Very interesting. So other cryptocurrency are coming up. They also have a market capital, and Bitcoin being getting the advantage of the being the first. It is one of the biggest right now. It lacks in terms of time it takes, the effort, proof of work, and few other things. So I won't be too surprised if some other cryptocurrency surpasses this in the future. But I think Bitcoin, calling Bitcoin tech as a lagging is a very wrong statement, because it also holds its place, not just because it's first, but on its merit. And they are also continuously improving the stack. Okay. So next question with Darshit, will exponentially growth of storage on hard disk does not create problem after 10 years? Good question. So I desperately left this point aside in this discussion because I thought I would be able to cover in due time. But this has been handled. What we do is, for all the old transactions, we create a Merkle tree, which is a technical concept and you can understand it, which makes it easier to save it. And I would suggest you go ahead and read the Bitcoin white paper. That one paragraph is there which answers your question. Is blockchain a cryptocurrency? Rishi Ratan. No, cryptocurrency is one of the application of blockchain technology. For any blockchain, we use a token or uh, quantifiable way of saying how much the reward is, and that turns up to be cryptocurrency. Okay, cool. So, do you have any follow-up question on my answers? Anyone? Okay, there are two more that I think. There is nothing backing crypto. Okay, I think I answered this. The future of Bitcoin is looking like. Well, to me and to a lot of investors, hedge funds, and other bigger organizations, future of Bitcoin and the crypto industry is bright. Why? Because right now they are getting established, and there's already billions of dollars of capital inside of this. People are using it to the major advantage that cryptos give us over the normal currency. The smaller countries can use it. uh, Relying on dollar will take a toll on them. Their own currency is not worth much in the world context. They can rely on one of the currency and benefit from the stability that it will give them eventually. Then doing transaction across border is very difficult because entire financial institution of each country is different, which crypto is easing up. multi sorry multi-chain transaction or are also getting a lot of traction right now, and that's also easy rather than so a swift transaction that happens like when you're transferring from Indian rupees to US dollar or anything else. It's complicated, time taking when you do it electronically. So that is also solved by Bitcoin. So a transaction that takes normally 4 to 5 days when you try to transfer money from India to UK also can happen quickly, like just like normal money transfer. So that's also one of the bigger advantage of cryptos. Plus, the possibility of fraud is highly reduced. So I think this technology has potential. Which of the crypto will come up on top, and they are point of debate plus something that we can only predict, not be not give you guarantee. But I think crypto technology is here to exist, and it's the world changing technology because in coming days will everything will have a blockchain aspect to it. Oh, that's it is saying thank you. You're most welcome. So I feel I have answered all of them. If there's anything else, please, yeah. Okay, so I think that the next question is to the panel. Can I get the recording of this session?
Yes, you can. You gotta install myCaptain app and you get support as one of the buttons wherein you just call and ask for the recording. They'll email that to you on your email ID. That is one way, and else you can even email it on support@mycaptain.in. You can go ahead and ask for the recording. And I'm glad you guys liked it. Robin, thank you.
Thanks a lot, Robin.
So there's one last question, Aruna. Would you like to take it?
Yeah, sure. The argument that there is a huge price volatility in cryptocurrency, do you think it will be able to replace the fiat currency because of this, the improved revenue? Yes. So this is argument is totally true. Right now, there is a huge volatility, but these cryptocurrencies are it's in their infancy stage. Like they're infant, they're rather very new. What will happen is, let's talk about 10 years from now, and let's say Bitcoin gets a lot of acceptance and adoption. A lot of things are happening on Bitcoin. Then this user sentiment. So a price of blockchain depends on its supply and demand, which will so what happens right now, supply is more or less constant or follows a pattern, but demand changes because majority based on some news, majority of the people will stop using it. or start selling it. So this demand is volatile. But when a lot of people are part of the network and they accept, a small outcry won't make an impact. The regulation that we have on stock market, which kind of limits the volatility, will be achieved here by a huge number of participant and active transaction that will happen. So if that happens, it will stay for longer. And if cryptocurrency are not able to do that, and the government wins, like they keep on banning it, it will be like the difficulty is there, the vulnerability of volatility. Yeah, I think I answered the question, Akhil. Okay, there's one more. Can we compare the current infancy of cryptocurrency with the technology internet boom around 98, which was initially not accepted, but later on, post the infancy stage, it spread like wildfire? Exactly, I think so. Yeah, the even the AI boom is in that transition phase. Earlier, people AI was a technology of future, but now it is existing and everyone is accepting it like crazy. Yeah, and blockchain will also have that thing eventually. Yeah. Anything else? Any other question? Okay. Thanks. You're most welcome, Robin, Akhil, and everyone who has asked question and enjoyed the session. It really feels good. If there's any feedback, negative or positive, do let me know.
Great. Thank you so much, Arunab, and thank you for extending it by 5 minutes as well.
No
Uh,
problem.
I'm gonna roll out a poll for you guys. You just let me know how did you like it, and please give your feedback.